today's audience has much higher expectations than the audience from 20 years ago. And they had higher expectations than the audience from 40 years ago. Engineering is about math and physics, and it's always about math and physics. That's what we build our work upon. I like the culture of Broadway. The folks on Broadway with whom I work are often the stagehands, the technical directors, the house crew, the people in the background, the scenic folks, the people in the background who are not getting Tony Awards.
Welcome to the StageLync podcast. Today we are talking with Bill Gorlin.
Bill Gorlin serves as the Vice President of McLaren Engineering Group's Entertainment Division, is a graduate of Cornell University, and is registered as a professional engineer in 26 states. His 38 years of experience include engineering of scenic, entertainment, and amusement structures, staging, rigging, theatrical infrastructure, buildings, show action equipment, scenic elements, theme park attractions, architectural theming, sculptures, and other frameworks worldwide. Mr. Gorlin is a member of the ESTA Rigging Working Group, ASTM Committee F-24 for Amusement Rides and Devices, and Structural Engineers Association of New York. Bill received the 2024 Backstage Legend and Master Award from the Broadway Technical Theater History Project and was named Engineer of the Year in 2018 by the New York State Society of Professional Engineers. Bill is the author of the Structural Behavior chapter in Entertainment Rigging for the 21st Century. Bill, welcome to the show.
Thank you for having me. I'm thrilled to be here.
We're so happy to have you, and personally very excited to talk all things technical, structural. With that said, would you care to introduce yourself a little bit in your own words? We Kat already read it in a very magnificent way, but in your own way, how did you end up working in entertainment? You're an engineer, and now you still do engineering, but specialized on entertainment.
So I graduated college, and like a lot of engineering graduates, went into the type of field that you were introduced to while you're in college. So, I worked for a small company in Connecticut designing buildings. And I was fortunate enough that we had a client who walked in the door who happened to be the owner of a scenic studio nearby, and they wanted a local engineer. And my boss knew that I liked unusual projects, so he just kind of pointed it to me and said, please work with this client. So they brought me into the world of entertainment, and it started with theater. And I really enjoyed that work. I enjoyed the challenges. I enjoyed the work with the folks in the shop. And I was in the right place at the right time, because that scenic studio happened to be peaking and also helping transition the New York Broadway theater industry and how they build shows. And I had no idea that I was entering into a place that was really riding a wave. And I just went with it. And I learned a great deal from the folks I worked with. And I just haven't looked back.
That's amazing, Bill. Thank you. Could you tell us a little bit about what it means to be an engineer for entertainment?
So, at the core, engineering is about math and physics. And it's always about math and physics. That's what we build our work upon. And if I'm designing a building, analyzing a building, or designing an amusement ride or a scenic piece or something for theater, it still comes down to the basics. It's still math. It's still physics. And it's all around us. So the challenge is being able to pivot and be able to work effectively in an industry that is not the same as the building industry or the bridge industry, and to learn the ways that people build sets, the methods for rigging, the terminology, and to be able to function in that environment while also keeping in mind my engineering background. As a structural engineer, which is my formal training, we're taught to look at how forces work in the physical world. And it's not just the structure of a building. It's the structure of the chair that I'm sitting in. It's It's the fence that I walk by on the street. It's anything in the theater. And so I'm always looking for the way things behave, more so than the numbers behind them. And I think in behaviors. And so when I interact with people in the theater industry and the entertainment industry, I discuss with them things that they typically should be able to relate to. And if we can find a way to connect in how we're perceiving something, even if mine is more mathematically based than theirs, then we're able to work together and produce something wonderful together.
That sounds like such an interesting way to collaborate, that the bridge between you is by thinking about the behavior of a thing. Because if you think about it, you have an artistic team who has an intention for how they want something to behave or how they want something to look or act. And then you're the guy who's going to help them make that happen, right? So what does that process actually look like? Like, where do you come in the timeline of a show creation?
Well, we're brought in at a whole wide variety of times. Sometimes we're brought in the moment they realize they have a problem and it's almost too late. And, that happened to us last week, in which there was, for one of the Broadway shows, they realized they had a concern, and we have to be very nimble in how we problem solve. Sometimes we're brought in way at the beginning in the early concept development stage and help them develop ideas so that the engineering is considered in the early development of a creative design, rather than having a design that's just based on dreams. But then when reality comes in, we sometimes end up, ruining the dreams, which we don't want to do. We want to enhance the dreams, or anywhere along the way. I think if I can add sort of a little background, when I was initially working with the shops, they'd call me, I'd go to the shop, the welders or the carpenters would explain to me what they were working on. I was very intimidated. I was not that kid who tinkered with his car. I didn't build things in a little workshop. I was not terribly handy when I was young, and so working with these folks who were very skilled at this labor, I found to be intimidating as well as inspiring. And I felt like I didn't measure up, because they could really do really good things with their hands. And so I just wanted to learn from the folks in the shop or the construction workers in the field. And likewise, I tried to find a way to connect with them. And so I would share with them what I was doing in a way that they could understand without having the formal engineering education. And then they, in hopes that they would share with me what they were doing, because I needed to learn from them, because I didn't have the practical experience myself. So that's a lot of the background. And then that's carried throughout the career. So no matter where we plug in on a project, a key thing is figuring out, how do we make the solution work for the end game? And it's, and if it's something at the last minute, you can't spend 3 weeks doing a complicated mathematical analysis. You have to find a solution that can be done here and now. And that can pertain to the physics and the math, but it also pertains to what materials can they get on hand? What can they physically handle on that site, given the conditions that they're contending with? And often it's trying to figure out what are the key things that drive this project, that are going to make this project really work. And it can be a very, very wide range of sort of key parameters to make a project work, which is a wider range than you might have if you're just doing building design of a certain type or bridge design. So I try to key into folks when we're getting into these problems, or these challenges, but we get involved all the time. For a Broadway show, we have a very good relationship with the technical directors. So we'll be invited in basically towards the beginning of when the technical director is brought into onto the team by the producers. And the technical director is the one who is pulling together everybody technical, the scenic shop, the specialists, and figuring out how to get the show actually built based on the designer's originally drawings. We're one of the specialists who get invited in at that period of time on a Broadway show.
I'm gonna ask for more of like, with maybe more specific in terms of, we've been talking about like broad general examples or a project, a big scope idea. But then I think it's a little vague Because if I'm a small theater company or a small dance company, I'm not going to call an engineering firm. But sometimes I don't even call it TD. But but when is it that you come into more so, or probably adding to Kat's question, and right, yes, in the timeline, but what kind of projects do you take on, and which projects do you think that can be, or that you don't necessarily will take on, that might not require an engineering expertise?
Okay, so I mean, we'll take on a whole wide variety of projects. I mean, we'll do projects that take 2 hours, and we'll do projects that take 3 years. And so we're happy to be involved in any project. Sometimes they just need some guidance on how to get through the process, and that may, like in New York City, which is where I'm located, often that process, the administrative process and the red tape for the building department is the big challenge, and they've been told that they need to have an approval for a set to satisfy the building department. We'll help on that process. We have a job coming soon in which there's a black box theater, and the rigging team looked at it and said, we're not sure we understand how the forces are working in this existing condition. Bring my team in to take a look at those structures. And I'm sensitive to the fact that an off-Broadway budget generally is very sensitive to extra costs, such as bringing in an engineer. And actually on this one, we've priced it so that we will come in, assess what's happening, discuss it with them, and then at that point determine how much farther we should take our services. And it may be that we're just advising the technical team rather than producing a design. Sometimes we'll generally want to become involved in a project as long as we can have a positive influence on the project. If there's a creative design that can be constructed conventionally, such as a lot of the scenery on a production, we won't be brought in for that. If it's an unusual piece, they'll involve us in that. Or if there's a regulatory requirement where you need to submit to building department or some other, will be brought in. Sometimes the owners have requirements where they want to know that there's a design professional who will sign off on the loads on the building, for example. It's a really wide variety.
It's interesting. You mentioned some off-Broadway stuff, and I know you have a really wide range of work that you do, but I'm curious, just in terms of the theater work that you're doing, do you find any specific challenges that might be different between older theaters and newer theaters, like in terms of your assessment? Or yes, you're nodding. So could you tell us what the difference is?
Yes. So, for example, if you go to a modern university theater that has that was built the 1970s or more recently, they will have lots of structure, lots of rigging capabilities, lots of space for storage, good electrical systems, and a lot of bells and whistles to facilitate the production. Then you go to the old theaters that are typically pre-Depression, that built before 1930, and it's a whole different class of structures. And there was a lot of theater construction going on in the 1920s. Right after World War I ended, and people were, the world was thrilled at the time, and there was money. And there were so many theaters constructed all over the country. So I've seen theaters in all corners of the United States that have a similar style of construction from the 1920s. And there was a wave in the teens and the wave prior to that. But in those days, the scenery was either built on site out of wood and and fabrics, or the heavy scenery was brought in on a push cart, or cart pulled by horses, and then the stage hands would carry it onto the stage and use hemp rigging, which the style that you would have on a sailing boat, and rig everything from that. So the loads that they had to contend with were very much less than we have today. They also didn't have the electric lights that we have today. So now you flash forward to the modern era, and how do you keep shows relevant to a modern audience in these old antique theaters? And it's a real challenge throughout the country. In the Broadway market, where there is a lot of money available to put on productions and upgrade theaters, it's been a constant challenge to upgrade them to the point where they can carry the loads of a modern, that's demanded by a modern audience. In the late 80s, the method of construction transitioned from wood construction to steel construction in the New York market. And that was, really necessary to facilitate some really big productions, such as Starlight Express, Phantom of the Opera, Cats. That coincided with bigger machinery and stronger machinery and electronic controls, and the weight that you put on the grid and the stage was significantly increased, and the dynamic forces associated with equipment was increased. But yet it was the same grid structure, same roof structure. So there were a few mishaps that I had heard of, but there's been a lot of effort in reinforcing theaters. Sometimes theaters would be replaced. I remember visiting a beautiful theater in Schenectady, New York, in which they completely replaced the overhead rigging above the existing stage house. And then once it was installed, they removed the old stage house. So it's a beautiful modern grid in a gorgeous antique auditorium. Broadway doesn't have that luxury because they always they don't have a lot of room.
Right.
But so it's a big challenge for us. There's a lot of guesswork. I wouldn't call it guesswork, but educated guesswork on understanding what the materials are and what the connections are, and working with the existing infrastructure. And we've come up with methods for gathering information from these old theaters and working with the owners or with the productions on finding ways around the limitations of the theaters or increasing them incrementally.
How often do you find you need to just tell a team, I'm sorry, but the venue does not have the capacity to do what you want to do. Let's just start over.
We get into that situation from time to time. I would say that in outside of the major markets, that will often cause a redesign, or reconsideration of the venue in which they're presenting the show. In the big markets, they will pump money in to find a way around the problem. I mean, we had a big show, Music Man, that was one of the big shows that opened after COVID, and they were building scenery for about a year, and it had two great stars, and it was in a big theater. And when they brought me in towards the end of all the stuff was already built, but towards the beginning of planning to go into the theater and actually start rigging, and when they showed me the weight of everything rigged in the theater, I took a look at this and I said, we reinforced this theater about 10 years ago, less than 10 years ago, and you're still more than 50% higher than what we reinforced to. So you better put your show on a diet. And they put the show on a small diet, but there was just so far they could go. So we had to reinforce the theater. And it was a really challenging situation because we have opening night was already established, and the scenery was already established, and the building is the building. So, fortunately, we had an excellent lead designer with the scenic contractor. We had one of the finest house carpenters in the business, and he was also the production carpenter, I believe. And the three of us got together and explored ideas for how to reinforce the theater. And it was a back and forth with the three of us bouncing ideas off one another. And we ultimately came up with a reinforcing scheme that was something that we hoped would not have to be removed, because they were spending so much money on the reinforcing, they would have to spend a lot of money getting rid of the reinforcing in the future. So if we
put
can
it back up in the next show.
Yeah. Well, the representative for the scenic contractor just said, if we're spending all this money, we might as well make something that will enhance the theater forever.
Yes.
That you don't have to take time and money to get rid of. So we worked very hard on doing the design, and it worked out. It worked out very successfully.
Nice.
Well, you've heard it here first, folks. If you have a big, heavy show, get your engineer in early.
Yes. Yes, we also had an interesting challenge when we were doing Cirque du Soleil's Ka production 20 years ago in Las Vegas.
I worked on that.
You did?
Yeah.
Wonderful.
That's
Yeah,
a beast.
wonderful.
Hats off to you for making it fit.
It was a monster. It was the process was actually quite fascinating because there were the original design called for. I'm going off on a tangent. I hope you don't mind.
Tangent away.
And the original design had a bunch of very imaginative effects that couldn't fit in the space. And so the creative designer, Mark Fisher, who's brilliant and open-minded, kept morphing what we were doing. And eventually the team settled on two very large pieces in the theater. One of the mishaps that in our design along the way was that the big stage that is suspended out towards the audience and then raises and lowers and spins and tilts and does all sorts of exciting things. And we designed this huge piece, and we were about 3/4 of the way through the design and realized that the brakes that we selected did not fit. And we had to redesign the entire thing for the brakes to fit. And that was one of those cases where it was really on us, and we worked extra hours and extra time to meet the schedule. But that was one of those ones where we really kind of got ourselves into a corner. And before that, the building kind of got themselves into the corner because the equipment was so heavy that the roof could not support the weight. And the building did not have the earthquake resistance to handle the extra mass that we had in the building. So we essentially constructed an independent structure to support this big stage lift inside the building that did not rely on the building.
And now, a note from our sponsor. The StageLync podcast is proud to be sponsored by Clearcom. Clearcom is the leader in voice communications for theater and the performing arts. Call your cues with the simplicity and elegance of Clearcom Intercom solutions. You can find them at clearcom.com. Go check them out.
From all those lessons and all this retrofitting buildings, are those lessons that if you are to advise a venue today that it's being built, do you look forward? How do you look forward to, I don't know, the next 50 years and make sure?
So, that's the big challenge. I mean, today's audience has much higher expectations than the audience from 20 years ago. And they had higher expectations than the audience from 40 years ago. And the big challenge is keeping the theaters relevant. There have been major advances in video technology and major advances in projection and in audio. I mean, all three of those have really just been incredible. But the audiences want more, and they're going to continue wanting more, and that's a big challenge. For my side, where we focus on machinery and structure, we can't change physics. It's still the same weight. And so the machine that was exciting to the audiences 20 years ago may not be as exciting today.
Mm-hmm.
But it's the same machine or the same cost of a machine as it would in correcting for the years. But so it's more challenging for the machinery and structures to keep up with the pace of all of the electronic equipment. So what's the future? I think the future is going to be, new theaters that can handle the loads, but also really all of the electronic effects, the audio, the lighting, the video, the projection is really the next step. And I also think that the changing the theatrical perspective for the audiences is a movement that's going to be continuing. There have been some that have tried, some that have been successful, some have not as successful, but I think it's going to be an ongoing development in the business, which means we could be transforming theaters into different shaped theaters. And we have a few of them in New York, such as Cabaret at the August Wilson, that we altered to become a theater in the round. So, there are several others that are, examples of that. So that those types of, transformational changes for the run of a show is an area where we're heavily involved, of course.
And who's to say maybe 50 years from now, the shows we're putting on are actually lighter because maybe audiences are looking for some different combination of technology that isn't as heavy. We have no idea, right? So it's an interesting thing.
Actually, you make a very good point. And that is the things may get lighter. The structural and civil engineering industries are generally slow to accept new technologies, and they really want to see that they're tested but there is progress that's made. One of the, I would say that 3D printing technology is in its infancy, and in our lifetimes, we may start seeing small structures like park benches and things of that nature made out of 3D printing, but we'll start seeing small buildings that are 3D printed, and that may influence scenery. There's also carbon fiber,
Yes.
which is an amazing material. It's just expensive to use and to fabricate, and it's challenging to repair if it gets damaged. But we've seen some successful implementations of that, for example, with some lightweight, sort of high precision LED screen systems that have used them. The tough thing is justifying the cost of a very expensive structure, to support something else. But that has a lot of promise, and I'm glad you mentioned that. Aluminum has really been the lightweight answer for many decades for the rock and roll touring industry, the temporary event industry, and to some degree the theater industry. I don't know if we're going to be able to afford titanium, which has some of the benefits of aluminum and the benefits of steel. It hasn't gotten there yet, but it has in other industries. So we may see some improvements in materials. That's a very good point.
Yeah, it'll be interesting to see. Now you do a lot of theme park work as well, from
Yes.
what I understand. Can you tell us a little bit about the difference between the process you might use for a temporary structure versus the process you might use for a permanent structure, something that people are going to possibly be climbing on or walking by and touching or walking underneath?
So that's a great question. And it's been an age-old challenge for the scenic studios to be able to pivot from temporary, just good enough for a show up on stage to something that is in a theme park that the patrons will interact with. The differences are very significant. So one of the differences is the interaction of the public with the elements, or if they're always away from the public and they never get to touch them, such as scenery on a proscenium stage. The demands for patron interaction are very significant in terms of fire resistance, just the look and feel, overhead safety, and and just people interacting and the abuse that the public may make on the pieces. And then you have the durability. We always say that the Phantom of the Opera was a temporary show that just happened to be 35 years of temporary.
Right.
And they kept having, and they did a great job, but they had to fix things over time and upgrade things over time. And they did a wonderful job doing that, but it wasn't envisioned to be a 35-year run. But a theme park attraction is envisioned to be a 20 or 25-year run, and a roller coaster, instead of being used 3 or 4 times a day like a stage lift in a Broadway show, is used once every 2 minutes, 16 hours a day for however many days it's open.
Plus, a little bit more.
Test and adjust in the mornings, and so the durability is a big deal. So things like metal fatigue. I'm sure you've never seen an amusement ride made out of aluminum. because aluminum does not last over many cycles of use. And when it fails, it's brittle. We like steel because steel will fail in a way that's more ductile, and you can calculate its ability to resist repetitive loads, back and forth type loading. There's also durability of finishes. The paints used on an amusement ride have to be able to handle the environment, the corrosion from humidity, rain, snow, temperature changes, and UV exposure, which can dull the paint finish. There's also the exposure to the electrical systems are exposed to to the elements. So they're all very different environments, and they can vary from location to location. We've had situations. We did a Broadway show in which there was one patron was invited up on stage by an actor, and I really put my foot down and I said, no, this patron needs features that are appropriate for the general public, not appropriate, and they can't get away with just features appropriate for cast and crew. So we had to have a proper guardrail and proper rise and run of the steps that was suitable for the public, and it just had to be. And we've had so the amusement park environment is very demanding, and the major theme park owners have developed their own internal standards that really reflect the increased requirements for a theme park attraction, both for the rides and for the theming, anything that interacts with the general public. And we have to be able to design for that type of demand.
You mentioned something interesting regarding regulation and standards and how each niche of the industry is creating their own, and there's some that are more regulated than others. For example, building construction have to go by the construction industry standards and whatnot. But then we have touring events or like more temporary, once again,
Right.
more ephemeral structures that might not necessarily or might be in a bit of a gray area. There is certainly an area of the industry that it's trying to address safety regarding that. But we're still talking about big loads, lots of people, a lot of movement. We still have wind speeds to consider, and like earthquakes and other nature forces that might be put into the structures. Is this something that you also can advise or that you usually address?
Absolutely. I'm heavily involved in that area. As actually, you mentioned that I'm involved with the ESTA organization. I'm on the rigging working group committee, and we write standards for the live event industry, which is utilized by by theater, by theme parks, by really everybody. And the regulatory environment is varies all over the country as well as all over the world. And in the United States, it's very challenging because we are essentially 50 some odd independent regulatory governments. The United States is kind of like the European Union. It's just we formed 250 years ago. So that construction is governed by the states, not by the federal government. So the laws in New York State are quite different than they are in California, for example. So if we have a touring production, we need to predict what the requirements are going to be in each of the 50 states, plus Puerto Rico and Guam or wherever we're going. And generally we'll have to comply with the most strict requirements. The challenge is you also have places like the city of Los Angeles, which has its own rules. New York City has its own regulations, which is different from New York State. And some of them are more conservative in one area, and others are more conservative in another area. And the regulations for temporary structures are not well covered by the building codes. There's been a big gap in the building codes for temporary structures where they have said it's up to the building official to determine what to do. But if the building official doesn't say anything, then just build it like a permanent building structure, which is absurd when you come up with a temporary stage that's up for 2 or 3 days. So the range has been anywhere from the building officials letting you do what you want because they're just happy to have something fun come to town, to other building officials who give you, who are scrutinized and give you a very tough time because they are not familiar with the temporary structures, and anything in between. And so there's been a wide variety of applications. The standards that we've developed with ESTA over the past 15, 20 years have really helped the industry gain some focus. And there's been a real big development in the model building codes here in the States. The 2024 edition of the International Building Code, I don't know why we use the term international. I think it's American arrogance, but that's what we call it. But the 2021 edition is the first one that includes a very robust section on temporary structures, which provides provisions for having reduced environmental loads for short-term use, and other provisions for that are sensible for temporary structures, including monitoring weather and wind in particular, and taking action. For example, if you can dismantle a structure or if you can evacuate the structure safely, they will allow you to do that. So we're heavily involved in that. We're kind of at the beginning of the code cycle of codes actually acknowledging the temporary structures. New York City has a code provision on it. There are a couple others dotted around the U.S. The 2024 IBC is going to become adopted by states and cities, I believe, starting in 2025, but they're at different times, and depending on which organization. Europe has its own requirements that can differ from country to country. We tend to have higher wind requirements here in North America than they do in Europe for temporary structures. But we also look at the Europeans for some things that they do very, very well, such as health and safety requirements and looking out for effects on the public. But the inconsistencies make it very challenging for us.
Well, because each region will cater to their needs, right? Like the U.S. have vast lands where tornadoes form really quickly, whereas I don't think that's very common in Europe.
Right, and actually the population centers in North America, the big population centers all have their extreme environmental conditions. Houston and Miami are extreme hurricane locations. Minneapolis and Boston have a lot of snow. All the California and the cities and Seattle have extreme earthquakes. I mean, even Phoenix has earthquakes, but they have extreme heat. So there aren't many big population centers that don't have a challenging environmental situation, and of course, global warming is making it worse. And that like the tornado alley is apparently shifting towards the east a little bit, and extreme conditions are becoming a real concern. And
it's harder to predict as well, which is your
very
job.
hard to predict. Yeah, the one tool we do have was hopefully people are aware and respect the effects of global warming and the weather impacts. The one tool we do have is improved weather forecasting.
Yes.
When I was a kid, you knew it was snowing when you saw snow. That was about it. And today, the weather forecasting tools are outstanding. I mean, they're never going to be able to say you're going to have, this tornado hit this location, or you're going to have a hurricane go to this exact location. But the ability to give you very good predictions that you can manage an event with is quite remarkable, actually, if you think about it. I mean, we had an event about a month and a half ago in New York City with an inflatable dragon on the Empire State Building
Awesome.
for a production. For a television show, and it was a marketing campaign, and it was wonderful. We had a weather information service out of Oklahoma who worked with us and gave us predictions for risk. There were two levels of risk. One was risk to the event happening, financial risk, and PR risk. For me, the risk was safety and not damaging the building. And we had, updates on a regular basis, and there was, a week out. 5 days out. And then they had, day 1, 2, 3, 4, 5, 6, 7, 8, starting from today. And then tomorrow they started with a fresh bunch of weather predictions, and they were quite good. And then we had live weather monitoring when the inflatable was up on the building, and they actually were telling back and forth to the crew saying, you have a storm coming in about 4 hours that may come to you. We're not sure it's going to hit you, but it may come near you. And then they said, okay, you're 2 hours out. You have a 2 hour. And they actually timed their work to get the workers off the building into a safe location before there was the potential for the storm to actually reach the building. So that kind of tool is quite amazing. And if used well, it can be a really useful tool to help for improved safety, but also to avoid false negatives.
Oh, definitely.
Real quick, I feel like throughout our conversation, we've covered different areas of the entertainment, but I feel like you were more excited when you were talking about Broadway and theater.
Well, I love all the various things that I'm involved in, but I have a special connection with Broadway. And it's not that I love Broadway. I love Broadway shows, but I'm not a Broadway show, fanatic. But I love the culture of Broadway. And, people have asked me, what's your favorite project? Right. Yeah. And, The Dragon was a great project, and Ka was a great project. And there were a number of others that are really cool to discuss at a cocktail party. But I feel that the most rewarding project for me has been the hundreds and hundreds of little tiny Broadway projects collected together as a portfolio to keep Broadway relevant and to fix one little ladder to make it safe for the stagehands and to improve, one little thing so you can put lighting in the right place. I like the culture of Broadway. The folks on Broadway with whom I work are often the stagehands, the technical directors, the house crew, the people in the background, the scenic folks, the people in the background who are not getting Tony Awards. They seem to be a group of people who really care about what they do because they love what they're doing, and they love the community they're in, and they don't need to have the public accolades. They don't need to brag that they were on tour with such and such a pop star. They're just happy to be part of their own group and they do it well. And I love being part of that community. I remember years ago going to the grid of a theater, and they said, "You're an engineer. What are you doing here?" And they didn't get me, and I didn't. We had to learn about one another. And now, when I'm in a theater, they say, "Oh, you're here. Good. I have something to show you." Or they'll say, "I've been wondering about this thing. What do you think?" Or I would explain something to them that they were doing that I didn't like, but I'm like, "Can you try to do it differently next time?" And then the next time they're like, "Hey, look, I did it this other way." So I love the culture. I love the people. And I love the fact that we've created something wonderful together. Yeah, that's why I love theater.
Well, you're talking to two Backstage people right now, and I think we'll both agree that, yeah, they're the best people in the whole world.
I agree.
Which actually does lead me to my next question for you, which is, what is your favorite thing about your job or about the industries you serve as a whole?
Boy, I think my favorite thing is I get to create things that are really that are meaningful to me, and I get to work with wonderful people and make wonderful things happen. And wonderful does not need to be this great sexy thing that impresses a non-technical person, but rather something that is useful, is meaningful, is helpful, provides safety. I think in 3D. I think visually, and I think in behaviors. And so when I'm creating something and working with a team to create something, that's really the most rewarding experience. And I can have a phone conversation with someone with whom I'm well connected, and we can have a full 3-dimensional conversation and almost finish each other's sentences and really understand that whole 3D behavior in our heads together. It's not about the math. It's not about the the formulations, but it's about visualizing the behaviors and then making them happen, and then seeing it for real. And I like to say to the folks I work with and collaborate with, look what you did. You made something really cool, really great that people are going to enjoy. And often in what we do, if the public doesn't notice it, then we did our job well. So I get very excited about this. I'm really into this. And I have to tell you, I was never a good math student. And I think that may have been a blessing because, and I was always a terrible computer person. I was not good in college. I struggled with the computers, and we were at the early ages of computers. And even in my professional life, I've always been kind of a C- student in computers. And I kind of think that helped because I didn't get caught up in the numbers. So.
Interesting. So if you could change anything about your job or the industry, what would you change?
Well, I don't know if I change anything with my job. I mean, I'm a realist. I know that there are frustrations that go along with any work, any profession. What I would change is as the world progresses, many people are spend more time seeing things that are virtual and becoming disconnected from the real. What I love about theater is that people are doing things that are real. I mean, it's, theater for elementary school children and middle school children, high school children is vital. Not necessarily telling them you have to become a theater person, but rather the experience of doing theater and doing something real. Just like sports, they're very similar. Just like music, they're all something real. And it allows you to learn how to problem solve and create things that are real. And too often things are done on the computer, and I've coined a phrase that my staff or I, using our computers, can develop a computer-aided catastrophe very quickly. When I started in engineering, we were doing a lot of things by hand, and you couldn't create a catastrophe quickly by hand. You make a little problem quickly by hand. And the expectations of the designers seems to be more tied into what they've seen on the virtual world on a computer than the reality. And that makes it really challenging for us to fulfill their dreams, because sometimes they'll come up with a design that has no connection to reality. And all we have to do and the only position we get put into is ruining their dreams because they can't realize it. I mentioned Mark Fisher earlier, who's, perhaps the greatest rock and roll designer I've ever worked with. And he was always connecting to reality. All of his dreams were right on the edge of being doable if you really worked hard. And
it was also
never
an architect. I guess that helped.
That helps. But there were some designers who have an incredible connection to the real world. And I worry about design being pushed by some designers and who may not have that practical experience with the real world, but just with the design world, and have a difficulty connecting to what can actually be made. It's creating a movie with CGI is different than creating a show with, live performance. And that live performance you can't replicate.
Bill, thank you so much. This has been fantastic. Thank you for being here with us and sharing your time and knowledge with us tonight.
Well, thank you both. And thank you so much for asking wonderful questions.
We learned a lot. I think this was a great session. Thank you so much.
Really enjoyable. I appreciate your time and appreciate you inviting me. It's a real honor to be invited to your podcast.
Absolutely. So great to have you, Bill.